Hello everyone, welcome to today's session. This is first of a few sessions on linear programming. In today's session, we are going to discuss how to formulate the problem, a linear programming problem. The upcoming sessions will discuss the graphical method of solving the problem and the simplex method as well the Excel solver method. First of all, we know that linear programming aims at optimization given certain constraints. Now, optimization in the sense that maximization or minimization subject to some constraints. Of course, differential calculus is also used for maximization. Programming is used in situations where the constraints are in the form of inequations and not equations. So let's start with the first problem to understand how linear programming problem looks like and how it is formulated. So it's coming on the screen. This problem, let me read it out. There are two products, product A and product B, uh, which is produced by a particular company. Product A has gives the profit of rupees 40 per unit. Product B gives a profit of 30 per unit. And, they are produced together. It is in the same production process in the same factory. The total capacity of this production process is 3000 megawatts. Production of A requires 3 megawatts, and production of B requires 1 megawatt. The market survey shows that the maximum amount of A that can be sold in the market is 8000 units, and maximum amount of B that can be sold in the market is 12,000 units. Now, given this information, let's first try to formulate. Let's go on to formulate the problem. Um, let's say x1 is the amount of product A that is going to be produced, and x2 is the amount of product B. The profit function will this form. We know that per unit profit from production and sale of good A is 40. Since 40 x1 units of good A is produced, so total profit from good A is 40 x1. And since 30 units is the profit from production on sale of good 2, so if x2 good 2 is being produced and sold, so the total profit will be actually fixed. So our aim is to maximize this profit. This is the objective function. We have our constraints. So this um, maximization is not done as such because there are certain constraints. What are we? 3 man hours required to produce 1 unit of good A. So total man hours from x1 unit of good A is 3x1 and 1 man hour from 1 unit of x2. So that is x2 unit x2 man hours. So this, since maximum balance is 3000, has to be less than equal to 3000, cannot exceed 3000. So either less than or equal to 3000. Apart from that, the market survey team has informed that X1 has a maximum demand of 8000. So uh, more than 8000 cannot be produced because that will go waste, that cannot be sold. So it has to be produced either 8000 or less than that. And same with good B, it has to be produced less than equal to 12,000 units because that is the maximum market demand. Apart from these constraints, since these two are quantities of good A and B, so there is one more constraint which is the non-negativity constraint. So they cannot be negative. So this is the non-negativity constant. So we have two decision variables, x1 and x2, and we have the constraints, the four constraints, the three inequality constraint and the one non-negativity constraint. We'll discuss the solution to solve in the next session. Okay, let's see the final. Let's have a final look at how the problem looks like. Now let's see. This is how the problem looks like finally. So we can see that this is the objective function. These are the decision variables x1 and x2. So this objective function tells us what is the objective maximization or minimization. And this is the constraint. These four are the constraints. So three are inequality constraint and one is the non-negativity constraint. Next, we move on to the next. So this is problem two. And so this is problem two. And a particular company wants to produce a dietary supplement and named it as Hypro. Hypro is going to have some nutrients like calories, proteins, vitamin E, and vitamin C. Hypro is going to be produced from three basic foods, which all three of them have all these nutrients in variable quantities. So these variable quantities are given in this table, and the amount of Hypro specification, which is decided by an expert committee. And so these requirements are given over here. Um, and also the prices of the three food items are. So we are going to formulate the linear programming problem with the constraints. So you can see these are the constraints because these are the minimum dietary requirement and the amount that is contained in the food items. So this is going to be a cost minimization. So next we move on to how to formulate this. Let's consider now, say amount of basic food 1 is x1, basic food 2 is x2, and basic food 3 is x3. Now, in this case, we are going to consider the cost, and so we're going to write the cost. Cost is C is equal to uh, first food item, that is 1, had per unit cost of 1.5. So we'll write it as 1.5 x1. The second one had 2, so it will be 2x2. And the third one was 1.2. So it will be 1.2 x3. Next we come to, so this is the cost which we aim at minimizing. So I'm writing it in short, that is minimizing. C, which is the cost, is equal to 1.5 x1 plus 2x2 plus 1.2 x3. Here we come to the constraint subject to the constraints. So the first one is the calorie constraint, and we have 350 x1 because good so basic food one has 350 per unit calories. Then we have 250 x2 and we have 200 x3 and the minimum requirement is 300. So you can see here is we have a greater than equal to constraint. Right. because 300 is the minimum requirement. So 300 has to be met, if not more. Next, we come to the protein constraint. Now, the protein constraint is 250x1 and 300 per unit of O2, so 300x2 and 150x3. And how much protein is required? I mean, slated, I is slated to have, that is 200. Next, we come to the vitamin A constraint, which is 100x1 and 150x2 and 75x3. And the minimum requirement is 100. Then we come to vitamin C, where also minimum requirement is 100. So the amount of vitamin C is 75x1 and 125x2 and 150x3, greater than equal to 100. And here also we have the inequality, non-negativity constraints, right? So these are the constraints, and this is the objective function. So this is a minimization problem. It will finally look like this. So this is the objective function. X1, X2, X3 are the decision variables, and these 4 plus the non-negativity 5 are the constraints. Right? So that's all for today. Um, and in the next session, we are going to see how the linear programming problem is solved graphically. So goodbye for today. Thank you.